the difference between augmented reality, virtual reality, and mixed reality. It is a range of experiences. On one hand, we have virtual reality, which is a total immersive experience where you put on a headset and you are disconnected from your environment. Everything you see and interact is a 3D generated object. And on the other hand, for augmented reality, you have a connection to your environment, like in HoloLens, and you have some extra information, maybe 3D or maybe audio information that's available to you, which is augmenting your reality. Also, we have mobile phone applications like Pokemon Go. You are looking through the glass of your phone and you're able to find 3D objects in the real world. And this whole range of experiences we call mixed reality. And short, it's called XR.
All right, welcome everybody to the session on the making of the SonzaiXR. Yeah, the presentation will be given by Pete in a video form. So let's watch the video first.
Hi, you've reached Pete Dakintis, spatial computing software engineer. This is my mixed reality avatar. So hello folks, so that was my avatar, but I'm the real Pete. So I work at Microsoft. I've got a background in 3D games and film special effects and those kinds of things. And I've worked a lot on HoloLens applications, and I worked more broadly, I suppose, on spatial computing problems, which involve workloads in Azure, working with customers and partners at Microsoft. This is a bit different, so we're going to talk today about an app called Sonzai, which was a sensory exhibit displayed at the Victoria and Albert Museum in London. So this was an opportunity that came along for me and gave me the chance to work with some fantastic creative people and hone some of my skills in that area. So before we begin, I'd like to take this opportunity to introduce some of the folks that I work with. So initially, producer extraordinaire Roland Lane. We have dancer Martha Bertholow. We've got spatial sound gurus at BAM Sound, including Scott Marshall. Dimension Studios, we'll talk a little bit more about what they did a bit later on. And then Prodigious and their creative director, Andy McNamara. And so a rough split on the app itself was that I worked on the sort of HoloLens related parts. Scott worked out the spatial audio, and Andy created the visual effects. So with a backdrop of corporate sponsors, including Epic Games and Microsoft. So already the term Sonzai invokes this sort of ethereal serenity and a sense of being at one with your surroundings, and that's really what we were aiming for, exploiting immersive visual effects, sound effects against the backdrop of the real world, using HoloLens technology to achieve that. Now this is the mood board. I hope this gives a sort of sense of the style that we're aiming for. So the inspiration that comes from this include brain activity, obviously the dance itself, hand interactivity powered by hand tracking on the HoloLens, and super cool visual effects and sound effects. Now The backdrop for all of this, as I said, was the Victorian Albert Museum, more specifically Gallery 87, including a backdrop of Turner and Constable paintings. So I'm just going to read a sentence to you from the original brief and the original vision. So a hologram appears in the prestigious Gallery 87, performing amongst an audio-visual environment inspired by the heightened brain activity that dancing triggers. Then, as the figure and plinth disappear, a harmony is reached with the physical space, as the digital environment becomes an immersive artwork, sitting alongside timeless landscapes from Turner and Constable, many of those featuring sort of water backdrops. So this image here shows Gallery 87, and I'm just going to play a clip of the, it's a bit of a teaser reel of the finished experience. So hopefully that gives you a sense of what we set out to achieve. Okay, so roll the video. So I'm going to talk now through some of the more technical aspects that went into the experience. So we're going to start with the volumetric capture of the dance performance itself. So here you can see Martha on the volumetric stage at Dimension Studios in London. So she performed there on the stage. She did her dance inside this ring of 106 cameras. So they capture both RGB and depth. And then using the sort of concept of reconstructing depth from multiple viewpoints, you can take a feature point in one image, and if you have another image that's taken at the same time, you can sort of triangulate those those points and work out a depth point for each pixel. So if we do that for a lot of points, we can sort of combine this idea and generate what's called a point cloud. And from this representation of a point cloud, we can then triangulate into a mesh, and that's what happens inside this process. So and when those when those meshes are compressed, we can sort of use the idea of a keyframe, such as you might do in video technology. So for the geometry, at a point in time of the keyframe, you have all of the geometric data available, and then as time progresses, you just use deltas from those keyframes until such a point at which those deltas are no longer useful, and then you need to create another keyframe. So then you introduce back all the data at that point. So you can see how this can be compressed in a geometric sense. So the results of that are called a track mesh, and these streams are then compressed and encoded, and all of that processing happens in the Azure cloud. Now, the final result of all of this is a streamable MPEG-DASH file. So that's kind of standard for adaptive streaming and playback. So you can see from this image, you can see the textures there, which will, as you play that video back, these textures are continually changing. And as I said, the way that the geometry changes, if you were to play that back on the mesh and show a wireframe of that mesh, you would see how the topology changes every now and again. Okay, so just to bring this home, if you'd like to go to the link on the slide on your mobile phone, you can press the AR button, so you can bring a hologram of me wielding an axe into your space, and you can place it somewhere within your room. I think most mobile browsers support this sense of this idea of web AR. And if you do this, please take a photo and maybe post it to Twitter or something. My Twitter handle is there on the screen, and you can also use the hashtag SonzaiXR. Okay, so I want to take let's switch over to Unreal Engine now, and we can see how this kind of an asset can be consumed within your 3D authoring package, and see how we can consume that inside a custom HoloLens application. So here we are inside Unreal Engine. I've got a plugin loaded which will enable me to play back and view the volumetric capture. Let's go down here and have it. You can see where the file is referenced, and what I'm going to do now is I'm just going to change the material. I'm going to change the material to a wireframe material so you can see how the mesh changes as I play back. So there you can see there's Hollow Pete in wireframe. Now if I go and play this sequence back, notice how every now and again the whole topology of the mesh changes. You can see it quite clearly there. Okay, so now I'm going to cover some of the more technical aspects of Sonzai, just to give a sort of flavour, an overview of what was required. I'm not going to go into too much technical detail. So as you can see from the slide behind me, we used blueprints, and we use those in conjunction with the Unreal sequencer. So there were a couple of points at which I dropped down into C++, but usually just to expose something from the mixed reality platform up into blueprints that maybe wasn't there before. For example, detecting if the app is in kiosk mode or not. And we'll talk about kiosk mode a bit later on, but you can see the blueprint behind me, and that's basically just to give an example. So when the app starts up, it will look for the existence of a spatial anchor, which again I'll talk about that in a second, and if there is not one there, then the app will go into placing anchor mode, and otherwise it will just continue on with the experience. So also we took the approach of using levels. So a level in Unreal is something that defines a scene. It defines a content. It defines a hierarchy of content which you can load and unload, and you can also do that asynchronously, synchronously. You can combine content from different levels, and then when you unload them they will get removed from memory. So we took that approach rather than sort of hiding and showing elements from the scene when they were not needed. So we use spatial anchors mainly to position the dancer's stage in the room, or in the location, in the gallery. Now a spatial anchor is a blob of data which defines like a position relative to other features within the room. So in general, as long as things like the lighting in the room don't change, or the positioning of furniture within a room don't change, then that anchor can be persisted across runs of your app. So you can save it to disk, and then your app can kind of check if it's there when it starts up. And as I said before in the original slide, if the anchor doesn't exist, then we'll set the app into anchor placement mode, in which you can use to specify a position which will define that anchor for subsequent runs of the app. So we didn't want to have any reliance on Wi-Fi, particularly in a public space where the public are going to enter. They have phones, so lots of Wi-Fi devices coming to the space. We didn't want to deal with the uncertainty that can bring. So all of the anchors that we used were local anchors. We didn't use Azure spatial anchors, and we had quite a lot of levels that required this feature to be able to load up anchors. So we created a little actor component which you could just drop into a level, define which actor you wanted to anchor, and it would automatically anchor that into the space. And in general, that was our dancer's stage. So that would sort of persist from one level to another, and from one app run to another. So let's have a look in this is a short video which will show sort of the app going into anchor placement mode. So I recorded this in the loft in my house. It's just running the app. The app will not have an anchor defined, so it will immediately go into the right mode. And there you can see this sort of placement 3D model, which as I move my head around, it will follow a ray from my head intersecting with the spatial mesh in the room. Once I'm happy with the positioning, I can issue an air tap and then the anchor will get created at that spot, and you can see there that the dancer's stage is positioned at that point. And you know, that can, throughout the exhibition, that anchor can persist on a specific device. As I say, unless the lighting changes, which we didn't have, but if that had have happened, then we could use the developer portal to go and delete that anchor, and you know, potentially we can share that anchor across over to different devices as well. So we used hand tracking, the hand tracking capabilities of the HoloLens 2 device to drive interactions within the app. So the HoloLens 2 tracks 25 joints on each hand. So as long as your hands are within, you know, the sort of volume of the tracking cameras, then you can get that data exposed up to your blueprint. And what we did inside the app was we chose a sort of like a central joint, and we used its position to drive a hidden actor, and we applied a spherical collider to that hidden actor. So we use that as that moves around. We use that to drive interactions, and we used it as an attractor to some of the particle systems, which we'll show in a second. Also, it's worth bearing in mind that you know, you don't really want to run this in your update loop. So I can't remember the frequency which we ran it, but it was much lower than you know, the 60 frames a second that the update loop runs in. Okay, so let's just roll the video, and you can see the real-time interactions happening as part of a mixed reality capture. So what you can see there in the centre of the screen is a giant digital dandelion, and I'm just passing my hand through it. And as I pass my hand through, you can see that the particle systems, like kind of electricity, attracted to my hand as I pass through it. We had multiple sort of interactions similar to that throughout the app. Now the sequencer in Unreal gives you a sort of editor's view of your whole project. So each level can have its own sequencer, but also there's like a master sequencer that you can use to choreograph each individual level sequence. So there does exist a little bit of overlap between what you might do in, say, a blueprint versus the sequencer, so it's worth thinking that through before you start your project. The sequencer in Unreal, it's like a non-linear editor. So you can sequence everything in your level. So you can control parameters on particle systems and actors. We could control the dancer playback, and you know, really orchestrate the whole experience. So for folks with a background in VFX and production, you know, this is very, very familiar territory. And I think it's fair to say that Andy spent a lot of his time in here. You know, really getting the sequence of the experience right. Okay, so now we've switched over to Unreal Engine, and I've loaded up the Sonzai project in there so we can have a bit of a closer look, with a view to looking really at how the sequencer works, but you can also get a sense for how the project's set up a little bit in here as well. So we've got a number of levels down here. We're actually looking at the master level at the moment. So in the editor preview, I can sort of zoom in and out. You can see some of the particle systems playing back. You can see the rotating sculpture. You can see the dancer who's static there. There are digital dandelions surrounding the stage, and there's a whole load of particle systems going off. You can even see some of the text overlays there sort of floating around in the background. I'm going to be a bit more specific. I'm going to load up the VFX level that we have. So let's load that. And I'm just going to adjust the view a little bit so we can see what's going on. There's quite a few particle systems firing off at the moment. Let's just zoom in a little bit. So there you can see the dancer behind this sort of curtain of digital rain. Now on the right hand side we have the world outliner. So there's a lot of actors in here, 3D models, polyps and so on. Stalks there, fronds, and we can find the sequencer in here. We can right click on the sequencer, And doing so, we can go and edit the sequencer, and that will open up the sequencer user interface down at the bottom. So here we have the non-linear editor, and we've got a lot of tracks in here. So we've got things like audio, we've got audio tracks, we have actors in here where we have parameters being hidden, shown, keyframe parameters on transforms, and we also have particle systems, so effects are being controlled from within here. We could also dive into the animation curves, but I don't want to go into that level of depth really. I just want to show you the sort of way that you can really choreograph these levels by looking at these tracks. So you can see it there. I also have a timeline. I've got some player controls here at the bottom. Now let's just give a bit more room to the editor preview, and if I drag the handle from the left hand side here, the timeline, so as time moves forward you can see the rotating sculpture, and at some point we have this sort of curtain of digital rain that begins around, and then the actual volumetric captured dancer appears in the center there. She will start dancing at this point, but that doesn't happen in the preview. We've got explosions emanating out from the stage, and you can see some other particle systems just starting at the top there, and you know, we've got these sort of fronds growing out from beneath the floor as well. So you know, if you're standing in the vicinity, you'll feel those start to sort of grow underneath your feet. So let's drag the timeline on, and we can see lots of things growing out of the floor. The digital dandelions are appearing. Particle systems are firing off inside those dandelions. Let's keep going, keep scrubbing forward, and at some point in time there's some more digital rain, and at some point in time the dancer sequence ends. I think it coincides with this explosion here, and we go into a sort of interactive phase. So it starts raining, and if you look closely you can see as the rain hits the floor, it causes this sort of ripple effect on the floor, and you know, you can almost imagine being inside this experience, but you have to layer on, you know, the soundscape, so you have to be able to hear the rain as it hits the floor, and you know, the audio tracks. As you move in, you will hear the spatial audio throughout the scene. So let's scrub forward, and we have some sort of digital snakes growing up out of the ground there, and let's just scrub through to the end, make sure I haven't missed anything. So this carries on a bit, and at this point the user would be sort of wandering about amongst this scene, interacting with the elements they're in, and we have another massive explosion there. And at some point there is a giant digital dandelion which grows up into the center of the scene that you can really go and sort of start to interact with. Okay, so I hope that gives you a sense of the sequencer and its sort of power. As I said, you know, you can use that in interaction with blueprints, and you know, really take control of what's happening inside here. So very much integral to the whole sort of Sonzai experience was the soundscape and the sounds that were applied to the visual effects. So very much in harmony. So when the digital rain falls from the sky, you can hear the rain. When you pass your hand through the dandelions, you can hear those things, and all of the sound effects are spatialized. And you know, any kind of mixed reality app with a soundscape and spatial audio can really be taken to the next level. You know, you can use spatial audio to direct the you know, the user's focus. So we had some particle systems which appear very high in the sky there, and you know, it would be very easy as a user to go in there, have this experience, and not, you know, you could miss elements of this depending on where you're standing in the room. So the use of spatial audio can really direct the user's attention to certain places, and it just applies another level of immersion. And the spatial audio in Sonzai was created by BAM Sound and Scott, who did an amazing job. So there were sound beds. Yeah, I mean, you have to experience it really to get the true sort of 3D nature of that. Now with HoloLens 2 display technology, which uses scanning laser, there's no persistence of vision there that you might get with an LCD screen. So dropping frames and not hitting a target 60 frames a second frame rate is all the more important. So it's worth really putting some effort in to make sure that you're hitting this frame rate, and you're not running the app and then suddenly the frame rate drops, or maybe it goes up, it goes down. It's really not going to lead to the best experience for your users, particularly when you want them to be immersed through the whole experience. So definitely worth putting some effort in, some time and effort in here, really. So with Sonzai, that was relatively demanding on both the CPU and the GPU, given its volumetric playback, abundance of particle systems, which all contrive to give the app its depth and immersion. And when you're working with a lot of creative people, they tend to add more each time. So every time there's a design review, the result tends to be adding something. So that really, you really need to have a counterbalance to that. Sometimes you need to not add those things if it results in a loss of performance. But anyway, if what you need to do if you've got an app and it's dropping frame rate, you really need to consider whether that the cause or the bottleneck there is the CPU or the GPU, and if you're constrained by your GPU, then optimizing the CPU is not going to help you in that scenario, and vice versa. So one simple check you can always do is that you can reduce the resolution of your target of your render target, and if that results in a higher frame rate, then you're probably GPU bound at that point, since you're calling shaders for fewer pixels. So if you need to go deeper and get a really deep understanding of what's happening in your running app regarding the CPU and the GPU, you can run Unreal Insights, and that will give you full kind of profiling information. You can see some of the depth of information you can get on the slide that's sitting behind me now. So we ran that a few times on Sonzai, and we found initially that we were CPU bound, and we discovered that to be associated with the particle systems that we were running. So we found a way to offload the particle processing onto the GPU. And that kind of resolved some of the frame rate issues that we were seeing, but then we found in some places then we were GPU bound, so we had to sort of go back and reconsider some of our shader usage and optimize some of the shaders that we were using. Ultimately we got to a state where we were pretty much running at 60 frames a second throughout the whole thing. I think there was a few minor frame drops throughout. Now, many mixed reality apps, get a real boost in usability by using some really clever mechanisms that guide their users on how, things like where to stand, what to do, and that kind of thing. I love it when I see new novel ways to do those things, but one of the tried and tested mechanisms to achieve a similar thing is using floating text with a voiceover. So as you move your head around, the text will sort of slowly lerp behind you into place, so you always have the text in your view, and you can hear a nice sort of professional voiceover at that point as well. So, but unfortunately, unless you have a radio voice, unfortunately I don't, then this can, potentially it can get quite expensive. You need to hire a voice actor, re-recording for different languages, and fixing mistakes that have been made. Maybe you need to call those voice actors back to fix those, and that kind of thing. So anyway, what I did for Sonzai was I used Azure Speech Studio, which I was pleasantly surprised by the results. So this this provides a number of things. So text to speech, and you can really get into detail editing inflections in sentences and phrasing. You can really control those things to a fine level of detail. With the out-of-the-box voices, you can also train a voice. You can train your own voice, for instance, and there's some other features in there which are quite nice. So what I did, I used Azure Speech Studio. I put in the text that I wanted my mixed reality experience to have, and I ran the processing on Azure, and I got back some text files along with some WAV files which had the recorded audio inside, and we'll listen to one in a second. But what I did also inside Unreal Engine is I created a reusable component which took those assets from Azure, so the WAV file and the text, and created the floating text and played back the WAV files so they could be used. You play one, something would happen, you play another, something then would happen, maybe there's a voice command in between, and then something else would happen. So there's a reusable component. We use that throughout Sonzai to sort of guide the user, help them understand where to stand, let them know when the experience had finished, and really sort of walk them through the whole thing. Now I've written a blog post on this, so you can go to the link which is up there. So you can go to that link and you can find the reusable code for that, and there's a blog post that I wrote describing it. And let's go and have a look at the results.
The word Sonzai when you have the device positioned comfortably.
Sonzai.
Welcome to the Victoria and Albert Museum. You are now ready for your Sonzai experience.
No HoloLens development talk would be complete without mentioning Mixed Reality Toolkit, in this case for Unreal. Now developers may be more familiar with the Mixed Reality Toolkit for Unity, so this is the same thing, it's got similar components, however it's been done in a sort of sympathetic to Unreal development, which is really nice. But so in Sonzai itself we didn't really have that much need for user interface elements, buttons, lists, those kinds of things. However, we did make a lot of use of those whilst we were developing. So we had a hand menu where you could press buttons when your palm faces upwards. You could press buttons on your hand and change some of the configuration options, which was really helpful and really useful while we're developing. So we also used optimized shaders from the graphics tools. We use tap to paste component, we use follow components, and we use some of the optimized text rendering in there. So whilst not front and center, it was quite a critical component throughout our development. Now it was important for us to understand the space that we were designing for, so we spent quite a bit of time in the museum. This was actually pretty cool because at times it wasn't open to the public, so we had, if you were lucky, you got a bit of time to explore an empty museum. So because of the scale of the holograms, what we wanted to achieve was that when the users entered the gallery, they would first witness the whole experience, but then gradually we would draw them in closer and closer until, in the last segment of the choreography we had the interactive elements, so they were then completely immersed in and drawn into that experience. So it's just important to understand, because you don't want to have your users miss some of the a lot of effort, some of the particle effects, and potentially if they're then standing up close there may be things that they're missing that's happening around them. Also a lot of effort went into the design of the floor. So if you notice at the start of this clip there are some fronds growing out from underneath the stage, and it's not really the illusion that we tried to create was of the fronds sitting beneath a translucent floor surface and then gradually fading into the floor. Now that illusion is not really achieved from looking at the comps that we're showing in this video, but when you experience this through the HoloLens device, you really get a sense that you're standing on this sort of translucent floor that's alive beneath you. So whilst you're developing your museum app, it's you're playing with all of the cool tech and all of the visual effects and that kind of thing. It's very easy to lose sight of the fact that this is designed to be a museum experience. So what we need to do as well is we need to plan how the public will move through that experience and really kind of optimize that experience to avoid any kind of situation where the user has to hand you back the device in order to fix some kind of problem that may arise. So as you see from the picture behind, what we had was we had the public coming in and they would view the teaser Sonzai HoloLens reel on a large screen there at the entrance, and we designed the app such that it would really run on rails, so it had voiceover, it had floating text to instruct the users to move from place to place and ensure that they had the best experience possible. So really going through really going through those walkthroughs and planning them up front really pays dividends when the users are there and when they're coming through at 10-minute intervals on the booking system that we set up for them. So as I say, what would happen is that the user would get handed a device as they came to the entrance. They would then issue a keyword, and then they would be enticed into the main gallery with a rotating statue and some holograms. Once they were in position, they could again issue another keyword, which would start the experience. So once the experience was started, the dance routine would play. At the end of the dance routine, there was a sort of interactive phase where the user could touch some of the holograms, and there was a digital rain sequence in there as well. And then once all of those things are completed, there was another voiceover instructing the user to remove the device and hand it back to the nearest instructor. So again, once that had finished, then the app would be sitting waiting for another user. So the device could literally just be handed on to another user. Having said that, we did have to deal with some of the COVID restrictions. So we had UV boxes. So a device was actually placed inside a UV box at the end of each user and was cleaned suitably. But the device would just keep running. The app would just be waiting in that mode for the device to be removed from the UV box and handed back to the next user. So really, we've got the experience to run pretty much on rails. To facilitate some of that, we set the devices into developer mode and use the developer portal. So each HoloLens device will serve up a little web app which enables you to set some configuration settings. And one of those settings that we really made use of was kiosk mode. It's really important because kiosk mode ensures that a user can't escape out of your app into, say, the HoloLens shell or some of the system menus, and that kind of thing. Because I think once that happens, it's quite hard. It's quite hard to work out that it has happened, and the user may not know what's going on at that point. And B, it's quite hard to get the user back without removing the device from them. So so we used kiosk mode and we kept the users inside the Sonzai app at all times. We also the Sonzai app used local anchors to position the holograms, and we made use of the map manager also inside the developer portal. So inside there you can save spatial anchors to disk, to a file, and you can load those back up onto another device. And you can also save the spatial mapping information from a device and load that onto other devices. So that was really important in how we set this up. There is one thing that I do regret not doing, and that is automating the whole setup of a HoloLens from the out-of-box experience. If you're going to do this, I'd advise having that automated. We did it by hand. We did it for 5 different devices, and it's very time-consuming and potentially error-prone. So thanks for coming to my talk. If you're interested in hearing more about Sonzai or HoloLens app development, please feel free to reach out to me using the contact details shown on the slide. Thank you.
All right. Thank you, Pete. All right, and for the Q&A session, I will also invite Andy to the stream. Right, and maybe you could introduce yourself and your relationship to this Sonzai project.
Pete, do you want to go first?
Yeah, hello. So yeah, I'm Pete. So if you just watched the video, that was me. I'm not in holographic form right now. But...
Hi, I'm Andy. I'm Director of CGI and Innovation at a company called Prodigious, which is part of Publicis Group, which is a big advertising agency group. And I was the main designer and creative, working with the director, and obviously Pete doing a lot of all the technical stuff really behind the scenes. So there we go. that's what we did.
Yeah, and I should say, just on that point, I mean, this was a really interesting, at least for me, it was a really interesting sort of collaboration between some great technical folks. So, it's a bit of a diversion as well from Unity. There's a question there for Enterprise AR. So I have used Unity a lot. I've used Unity a lot, and I've used it for most of the HoloLens apps that I've developed up to this point. I had sort of tinkered about with Unreal, but this was, for me, this was really quite a learning experience. I've done a few things with Unreal in the past, but not really built anything like this. Just to cover, you asked about the toolkits. So what I would say is that the Unreal MRTK folks have done a really good job in quite a short space of time, and there's nothing that I wanted to have in that toolkit for this app that wasn't there. So I would say they've done a really good job. I mean, what were your thoughts, Andy? So I think this was a bit of a learning experience for you as well, right?
Yeah, absolutely. I think this was the biggest project we'd sort of done with Unreal. And obviously, I think what was interesting is there was a number of disparate technologies that we had to figure out how to use together. So obviously, the volumetric capture stuff, as well as the HoloLens and limitations of what we could do with that. But also, as well, a lot of the environmental effects using things like Niagara for doing the particle systems, performance optimization. So I think there was an awful lot of integration there, as well as it was quite a very, very large physical space that we had to fill an anchor to. So Pete did an amazing job of trying to optimize the performance on how all that worked. I think it was something like 20 feet across. So obviously to keep it rock solid locked to the ground was a bit of a feat. And there was an awful lot of things going on that were thrashing the CPU and the GPU. Wasn't it?
Yeah. Yeah, and there was some, for me at least, there were some sort of really quite interesting things about, how we work together on this as well. We sort of experiment a little bit with, using Unreal levels, loading those in and out, and the sequencer, which I think I mentioned that, Andy, you spent a lot of time in there. But we sort of had this tension between, I was doing some things, inside blueprints, and Andy spent most of his time more in the sequencer. And I think there's really a sweet spot that I don't know if we got to that, but I think we would have got to that at some point. We would have worked out how to, make the best use of that kind of development.
Yeah, there's a lot of really cool collaborative working tools used on sort of like obviously large productions. I mean, this was quite nimble in how we actually had to work together. So obviously using the level system, streaming them in, working on our own partitions was quite useful. I mean, obviously on big game projects, it's an order of magnitude more complexity. Then we got a question, Pete. Beyond project.
I wanted to mention it. So it's about publishing the project. So this whole the distribution system is like more easy in Unreal. Do you have any thoughts on that? Is there
I mean, I don't know how far this question goes in terms of, I mean, are you taking that and putting it in a store somewhere? Because that. With Unity, I mean, I think the thing that I sort of struggled with a little bit is the fact that, the developer loop can be quite long at times. You sort of author things inside Unity, and then when you do a build from Unity, that builds you to a Visual Studio project. So you then go into Visual Studio, and then you go and build and prepare your distribution from there. So it's sort of like this two-step process. And if you're you really have to think about how you're going to do that as a developer, because doing that each time you make a very small tweak is is not very useful. So sort of try to optimize my time in the editor and sort of spend long periods of time in the editor, and then only sort of distribute or build every now and again. I'm just gonna read the follow up to that, because Enterprise AR hasn't put another note in there. Yeah, I don't think I'm qualified to answer that, in that we didn't really build this to ship. So the process that we sort of had on this was that Andy and I worked on a code base, and we use Git, we use Azure DevOps. So we had the code in the repo there, and we used Unreal's sort of Git tie-in to work on content therein. And when it was time to produce a build, we would run the built-in sort of, I can't remember what it's called inside the menus, but you can create a build inside there, and that would produce you sort of app package, which you could then take along, and you could install that. And we did that mainly via the developer portal.
I think what was interesting, though, wasn't it? It was even that's quite a tedious process, because it's the only way that you can deploy to the device. So every time even we made a small tweak to the code base, either even graphics or blueprint tweaks, we had to upload and redeploy. So I don't think there's a speedier way of doing it, but even that was it slowed the process down a bit. But I don't think there's a way around it.
No, and as I mentioned in the video, I mean, if anybody's listening to this and thinking, we're going to do something similar, we had like 5 devices there, and we had to prepare all of those devices. And what I would reiterate, and if I did this again, I would make sure I automated that, because it's quite, it's fairly tedious to go through the out-of-box experience. Well, to be honest, the out-of-box experience is very pleasant, I must say, and the folks that designed it have done a really good job. But when you get to the 5th one, it starts to become a little tedious. But there are ways to automate all of that. So that's what I wish I would have done. I notice Enterprise AR. I mean that is something that I'm going to have a look into since you mentioned it. So it'd be great if you could just describe what it is that exactly that's causing the pain in that scenario.
I think he's talking about the App Store.
Yeah. I think it's interesting, the whole point of Unreal versus Unity for this sort of development. I think one of the reasons we chose Unreal. Originally, this project started completely differently. It was going to be a Magic Leap Unity project, and then we moved it to Unreal and HoloLens for a number of very good reasons. And that Magic Leap was no longer supporting the project. But I think what we found is, because this is a really graphic heavy project, that we needed some flexibility to allow myself as a CG artist and a developer to actually really, really tweak things very precisely. And at that point, Unity wasn't allowing us to do everything we wanted to do to iterate fast. And I think this is the difference between really heavy graphics XR projects and things which aren't. And we find that Unreal with the sequencer allowed us to very quickly nail the look and the process, because it's a very linear sequence with some interactive bits to it. So we've got some more questions.
Another question from Roland. Or you had a comment, Pete?
I was just going to address the one above, which is Enterprise AR there, mentioning about the Unreal App Store. So you probably know this already, but Microsoft App Store is open for business, and it's kind of well documented that Unreal could have a presence inside there at some point. So yeah, I think that's really interesting when and if that comes about.
Roland's got an interesting question actually about performance and the volumetric video. I think what was interesting, we had a bandwidth or a budget that we had to deal with per cycle, and I think obviously the volumetric performance was really, really important, so it didn't skip. And whatever was left, we used judiciously across everything else in terms of the environment effects and optimizing, poly budgets and performance stuff. I can't remember what the overhead on the processor was for that, Pete, but it's quite an interesting question.
Yeah, I guess we'd have to have a look back. I mean, obviously the decoding of the MP4 is done in hardware. And it's you can adjust the bit rate of the and you can tweak and optimize the volumetric playback, and some folks at Microsoft who work with these things helped us with that. So we had a pretty well optimized volumetric capture, and that really helped us, because it's easy to imagine that could take up a lot of resources on the device. And when you experience this, I think it's quite amazing what this device has been able to do. It's quite incredible.
Yeah, the device got very hot. That's all you need to remember. It was doing so much by the end of it across the GPU and CPU pipelines on the device. But as Pete said in the talk, we had to load balance across both. We started off maxing out and being CPU bound, and then we had to shunt some of the processing back onto the GPU, which wasn't doing anything. So that was
it's a sort of the project worked out really well in that, when I mentioned this in the video, it's like, when you got creative folks, they do tend to add things, and I think I was probably like, I don't know, a little bit of the voice of reason at some point. Say, come back, folks. This is not going to work. It's gonna, we're going to start dropping frames, and when that happens, the user then doesn't get the best experience. And we had some amazing feedback, I must say, and folks were saying things like, we love doing the experience. It was amazing being in the surroundings as well. I think that a lot of them were blown away by the fact that they could see all of these, amazing Constable and Turner paintings hanging up, and yet they were seeing in that space, this sort of cornucopia of visual effects.
Yeah. Interesting question about Unreal and Unity. It was build less bumpy interactions, public is more polished. Yeah, I just think I've used both, and I just think Unreal is a pleasure to use. I mean, it's not perfect. I think certainly, even the animation components of what we were trying to do beyond the volumetric were really heavy. We had something like anything up to 200 animation channels going in one go, and if you've used packages like Maya or content creation tools, they're a lot more polished for dealing with that amount of data. But we thought that we don't think we would have got as far as quickly if we did this project in Unity.
All right.
yeah. I mean,
nice comment.
Yeah.
So I mean, those things are very different, though, aren't they? So Unreal is native C++ already, whereas Unity, you go and develop in .NET, and then that gets built down to C++. So, and that is not without its problems. And, you can find things in there where the, that conversion process has kind of introduced those problems. It's amazing how that thing works and how it does what it does. It's quite sort of, boom. So I think the Unreal thing, the point you make, it's kind of less bumpy. I suppose it's just compiling the C++ at that point.
All right. Yeah. They're definitely different, and it's good to have options. I think both ways you can get it working, but one thing may be easier in one engine than the other. We're almost out of time, actually. I had one question, because I have not so much experience with this heavy graphic intensive apps, but did you consider remote rendering that's also available for HoloLens?
That's a really good point. Yeah. After you, Pete, sorry.
Well, I was just going to say, my experience of doing events where there are lots of people with mobile phones, having any kind of reliance on Wi-Fi is potentially a bad idea. Otherwise, we could have rendered on a machine, sitting in the corner.
That's what I thought. But you're right. And the Wi-Fi would still be impacted by the noise. Yeah, I did notice that once as well. It's very interesting how that happens. Like everything works when you test it, and then all the people come in.
I guess ultimately with things like 5G and, obviously the noise around the metaverse and, streaming from the cloud, it's less of an issue in 5-10 years time, because I think everything will be sort of infrastructures will be in place. But in a museum environment, it's just absolute nightmare. I've done a few events type things, and it's always the Wi-Fi that's the weakest link, because it'll drop out, and it's really dull.
Yeah, well, I've done a few events where, we're sort of reliant on the Wi-Fi, and you can go and do a test when there's nobody there. Everything works fine, and then as soon as lots of people come in, it won't work, and it's a bit of a killer, really. So yeah, we just wanted to take that out of the equation for this.
Yep, and if it works, it is a more easy setup. Right, and like in the future, like HoloLens 3 will probably be able to have even more rendering capacity. We'll see, yeah. Very awesome project. Yeah, I really like to see these visual effects. I hope that there will be more of that. I think that can really bring the holograms to life. And
fun to do.
That, yeah, I would like to close the session. You probably could continue talking about it for a bit, but we already over time. So thanks, Pete. Thanks, Andy, for joining. And enjoy the rest of the Global XR Con. Okay.
Yep. Thank you.
Thank you.
Thank you. Bye.
Bye.